Okay, good morning, everyone. Thanks for coming, and thank you for the organizers for putting this section together. And my name is Chusen Wu. I'm from the University of Tennessee, and my co-presenter is Steve Greenberg from at Google. And unfortunately, he could not be here today, but we have worked together to prepare this presentation, and we try my best to represent our work as effectively as possible. And our title is Interactive Analysis of Satellite Imagery with Google Sensing and Geemap. You can scan the QR code at the lower right corner to access the slide if you want, and also the link at the bottom there to get access to the slide. And here's the outline. First, I will introduce an interactive web app that allows you to create satellite time-lapse animation for anywhere around the globe using all kinds of satellite data. And then I will briefly introduce Google Earth Engine and Geemap. Then I will highlight some of the key features, what kind of things Geemap can do. And lastly, we'll show you some additional resources. On the right here, I show you an animation. That one is actually a Landsat time-lapse animation. And you can see how dynamic the river channel is changing, and not just for visualization, so you can do also all kind of analysis to extract features from the satellite imagery, all without coding. So if you know you're interested in, you can check out the link upper right corner there to access the web app. And so here's the interface, and you can besides the Google Sensing, there are all kinds of other open source applications for you to visualize data. And here I'm going to show you a quick tutorial. All you need is just zoom in to anywhere around the globe you like. Simply draw a rectangle, or you can upload an RI from your computer, and then just select what satellite do you want, Landsat, MODIS, all kind of satellite in the public domain, and then just adjust some parameters, click the button. Within 20-30 seconds, you should be able to get an animation for any area you like, and to show how the landscape is changing. It depends on the satellite data. So for Landsat, we have that since 1984. So we have 30-40 decades data. They can see the changes, and it's very effective. And this is a simple tool that you can utilize to showcase changes. Next, I'm going to quickly show you some examples that are quite interesting. For example, the drawing of the RC, mining in Canada, coastal expansion in Dubai, and also the river dynamics improved that I show you at the beginning. And deforestation, landslide, quite interesting, right? Lasting for decades of a landslide. It's difficult to see on the ground, but with longer time series, it's actually quite striking. And the famous urban growth in Las Vegas, and also see the reservoir, how it's changing. Urban growth in China, in Mexico, coastal erosion in Spain, right? And so those are just the longer time span of the Landsat data, but there are tons of more satellite data available. So this is for Landsat, for example, temperature within 24 hours, right? So we have data every hour, right? You can basically visualize all kinds of satellite data very easily, and you can create the animation. So next time, if you see some of these on social media, you can try to create one by your own, because now you know you have the tools, actually you can do that. But under the hood is a lot of computing actually to be able to generate something like this. And traditionally, it's actually very difficult. So you have ever using remote sensing data, trying to create this maybe 10 years ago, this can take you hours. You download the data, processing, remove cloud, and then mosaicing, all kind of stuff, and then to download. So now it's simple, 20-30 seconds, anywhere you like, and all kind of satellite. So this is for temperature, but certainly you can do other, for example, sea surface temperature changing dynamics, or even vegetation dynamics, right? So if you're studying how the vegetation is changing, this is quite effective. And you can see how it's actually the phrenology is changing throughout the seasons, right? Just like human breathing like this, but the Earth is actually very vibrant and very interesting. And those are relatively longer time span, like high tempo, low tempo frequency. But sometimes we need some very high tempo, like every 5 minutes, every 10 minutes. In this case, for example, the famous Tonga volcanic eruption, right? If you see here, you can capture the satellite data, can capture the event, and then can showcase how the impact of these kind of natural events. And on the right, show you the wildfire, right? Wildfire exploding, especially in California, and they are it become more and more frequent in recent years. And not just for visualization, you can also do analysis. You can actually check how the wildfire boundary is spreading. And these are very critical, especially for disaster and evacuation events. You need to know where it's going and how it's going and where it is right now. So all those things information we can get through this kind of satellite data. So these are some of the simple examples. As I said, anything happening on the Earth surface, usually at a certain scale, it can be captured by satellite data. And with a longer time span, 30, 40 years, we also have data that have taken very quickly, every 5 minutes, 10 minutes. So most of the things that we can capture, we can analyze. And not just visualization, the more important thing is to ask the question, why this is happening and how it is happening and where is it going, right? So those are more like scientific questions that people can think about and how to address that. And the app that I created is under the hood, empowered by Google Engine. So Google Engine is a cloud computing platform that can process petabyte data and very efficiently, and it's free for research and education and no profit. So you're welcome to sign up. And one of the questions you might ask is, why do we use Google Engine, or why don't we just use the desktop to post the data that we have been doing for decades? So Google Engine is based on the cloud, so all we need is just a browser, and you can do like petabyte scale, at national scale or global scale within a couple of seconds. And you don't need to download the data. Just imagine, like in the past, we watch a movie, we get to buy a DVD, we log into the CD-ROM, and you need a decent computer to be able to see that. Nowadays, you just YouTube, Netflix, right? You just watch a movie, search, then you watch. Nobody really download the movie anymore, like to a local computer. Of course you can, but just like you don't want to, you can just use a laptop, your cell phone, anything to watch. So the same idea here in the geospatial domain is that we're transforming from the desktop to the cloud. And so Google Engine has over 80 petabyte data in the cloud. Most of the data in the public domain are already ingested. So you can use it in your fingertips, and you can use Python, you can use JavaScript. It also makes it much more accessible and reproducible. On the right here, show you a diagram of all the journal publications you see using Google Engine. So you can see the exponential growth of users using this to do organized scientific studies. And one very simple application of Google Engine like this. So we have satellite data, we have optical data, we have getting data, like for example, for let's say every 2 weeks, right? And throughout the year, you get like a bunch of images for the couple decades, right? So cloud is a big problem in remote sensing, for optical remote sensing. And essentially what you can do is take a bunch of low quality images and then generate something like this. So similar to on Google, so what you see like it's cloud free, it's perfect. But in reality, it's actually under the hood using compute engine to process a lot of images and then to generate something like this. So the image you see here is not taken from the same day. Every pixel comes from a certain day, and then you put all the pixels together. So the simplest one is take a median value. Like you have a lot of values, and the cloud are usually high value. So you have a time series, every pixel, you get the median usually is pretty good. And then you put all the pixels together, it becomes an image like this. So this is just like magic, and in Earth Engine is blind code, and you can do that at a global scale for any data you like. So it's very simple and easy to use. As I mentioned, it has over 80 petabyte data, so 80,000 terabytes. As long as you know how to access that, it's 1 to 2 lines of code, and then you can not just access data, you can also do processing. So not just for visualization, there are a lot of things you can do, and all the data, Landsat, Sentinel, MODIS, if you're familiar with remote sensing, pretty much any day, most likely the data set you're using is already in the catalog. If not, you can upload your own data, and then you can utilize the parallel computing. So this is the so-called JavaScript code editor. It's very easy to get started, and so you have a lot of functionalities for you to explore the data and then write code, visualize the data, analyze, and then get some figures on the right here. And it has a long history. So it started in 2010, and then around 2015 released for public application, and then a lot of people build on top of this one. So JavaScript is very easy to get started, very powerful, and it has a good user interface. So you can think about Google Engine has two components, the compute and also the visualization. So the JavaScript can do computation, it can also do visualization, but the Python API is just for computation. It has very limited visualization functionality. And the reason why we want to use Python is because we want to utilize the Python ecosystem. We have a lot of visualization libraries. We have desktop, we have ArcGIS, we have QGIS, and you also do a lot of machine learning stuff. So we want to actually utilize the Python, and you can also use the IDE of your choice, Visual Studio Code, Python, whatever you like. So Python to me is much more intuitive to me. And so that's why I built the package called Geemap, kind of building on top of the Google Earth Engine computation API, and then I have all the mapping libraries actually to be able to visualize that, and also utilize SciPy widget to do create all kind of interactive widget that allow users to interact with the Google Earth Engine without having to write any line of code. And so next, let me quickly introduce Google Geemap. So it's an open source packages. You can check out the source code on GitHub. So I started this one roughly 3 years ago, and it has grown a lot of users right now using this to do mapping and visualization using Google Earth Engine. And it support Jupyter Lab, Google Colab, or any basically Jupyter based environment. And you can check out the website geemap.org. There are tons of documentation, API, examples, tutorials, video, like that. I also published a short paper describing what this is about, and I was lucky to get support from NASA to help maintain and develop the package. So next, I will show you some tutorials. You can check out my YouTube channel. So I published over 500 videos with length over like more than 3 days. So you can, if you like, you can check out a lot of tutorials on my YouTube channel. And also for Geemap specifically, I created 137 notebooks. So each notebook basically introduces one feature, one key feature of Geemap. I will show you some demos later, but what I'm showing here is probably just 5% of the features that you can use with Geemap. So each tutorial has a full-length video, maybe 15-20 minutes, and a GIF animation like highlight 10-20 seconds, and also a notebook that you can reproduce. So all you need is just an account, and then just run through Colab or Jupyter Lab, whatever you like, and then you can see, you can reproduce what I did in those videos. But I take like each video 10-20 minutes, but some may take 10-20 hours to actually to implement the feature, and then to be able to actually showcase that in the notebook. And also I'm writing the books, so you can check out the website, the link there. All the source code are open source, open access. You can check out more like 6-10-minute introduction into the package, how you can access the data, visualize the data, analyze the data, export the data, or create a map that you can use in your report or in your publications. Okay, so next I'm going to show you like more visual impression, like what kind of thing you can actually do, right? It's building on those big cloud computing, but I want to know like what I want to watch a movie, how to actually watch the movie, right? So in this case, I want to access the data, how to actually access that, how to visualize that using the package. So the first one is the automatic conversion from JavaScript to Python. If you're already a JavaScript user, a Google Earth Engine user, you might want to try this one because just copy paste and it can convert the JavaScript API to Python, and then just one, you can get the result. So you can see here, like you want to get access to the imagery, just couple clicks, then you can see what the imagery look like. You can also search the data. So this is similar like you search a movie on the internet. You can search any data you like in the data catalog, for example, lane cover, animation, anything you like. Select import run, you see the data. So you have the point to the data. It's not just for visualization. You can analyze, you can do all kinds of things you want. So lane cover, right? In the past, you have to go online to download gigabyte of data, and then to load into a computer and then try to do analysis. Now you don't need to. All the data in there, you just need to know how to access that, right? And think about in a couple of years, for example, Landsat Next is going to be launched in 2030. And right now for Landsat 9, each image, each one satellite sync is 1 gigabyte. So in the next Landsat generation would be more than double the spectral band and the resolution from 30 to 10. So basically the size is going to increase from 1 gigabyte to 20 gigabyte in the next 7 years. So basically you have 7 years to prepare yourself for the next generation. You don't want to download 20 gigabyte or one small piece of imagery to a computer to process. You probably want to try out the cloud. So this is what you can actually utilize, and you can also use the inspector. So Geemap basically all about, in the right here, all the widgets, right? You just need to click, and then you can inspect, for example, the pixel values to see what the value looks like, or the vector data, raster data, something like that. So it's very easy and intuitive, just similar to the desktop GIS software. And you can also do plotting. For example, sometimes you might want to see, for remote sensing, you want to see the spectral value to see what the feature looks like, right? For vegetation, for water, for buildings, anything like that. You can also do hyperspectral data. So if you have interest in using hyperspectral data, you can also do some simple plot. It doesn't look that nice, but you can customize. You can use all kind of plotting backend you like something like this. You can visualize raster data, so you can change the color map, you load the imagery, you want to use some different color palette, you can also just do that interactively. Or you just click the button, select, and then you can change everything just like what you used to do in desktop.js. You can create some map to do, for example, simple comparison, right? You can do global scale, lane cover mapping, like all the data are available. You can do compute and then just visualize them side by side. Basically, you have the original data, you have your classification, you have your prediction, whatever, and you can do some simple visualization. It can also integrate this with desktop.js, for example, ArcGIS, QGIS. So traditional desktop right now, you can basically access the data catalog because they support Python. And you can run the notebook interactively within the desktop.js. And so in that way, you have the power of using, so basically you're streaming the data. You are not actually downloading data, just like you're seeing the Google-based map, right? You can pull the Google-based map on your cell phone. You don't actually download the data to your computer. You can also create some high-quality maps for publication, for the journal publication or report, something like that. So it support all kind of different projection. And essentially, it's downloading the data layer and then create a map, and then depends on the projection you want. Basically, it supports this kind of plotting capability. So that it's not just for within the interface. Sometimes you want some high quality figures. You can do that as well. And lastly, you can also, once you create something like this, you want to make it accessible to other people, you can also utilize Geemap to create the web app. So the web app allows you to basically be on top of Geemap and SciPy widget and others. So you can just simply transform your Jupyter notebook into a web application within a couple clicks. So I have a lot of examples on my GitHub. You just clone the repo and then deploy, for example, Hugging Face or any other project you like, and then your app will be up and running. So in that way, if you're academia, right, in traditionally you have to like post your data somewhere on your server or in the cloud, and then people need to download. But if the data is pretty huge, like gigabyte data, people don't want to download. People want to see what it looks like before you actually spend a lot of time and bandwidth to download the data. And this makes it possible. So you can host the data and your app in the cloud. You send the URL, you can embed the URL in your manuscript. People try it out and see it. So I think this is the future of the geospatial and also internal publication, makes things more reproducible, more accessible. Personally, like if I publish a paper, I publish something, I want the people to see it. I mean, in a web app, in some interactive way, not just like, it's good to post the data somewhere, but it's not good enough. Not everyone have the ability to download all the data, have the desktop.js to load the data and to visualize that. And this just makes it so much easier and it's reproducible, because what you do, people run it, you can get the same result. So in that way, you don't have to like manipulate, because a lot of publication people manipulate. You can never reproduce what's put in the journal manuscript. So this is, I think, something that is very powerful and very useful. And lastly, I want to show you there are a lot more additional resources on GitHub, but I presented a tutorial on Tuesday. It's basically about Geemap and Google Search Engine. It's 4 hours long, and I have a Jupyter notebook here in the link. You can check it out. If you want, you can go through and you can reproduce what we presented. And nicely, because I record the video, so you can also check out the video, the 4-hour YouTube tutorial on YouTube, and you can follow through. If you have any questions, you are welcome to reach out or post questions on GitHub. And if you have any questions, you can scan the QR code to connect with me on LinkedIn, or just type the URL, and I'm happy to talk with you, answer any questions that you may have. Thank you very much for your attention. Thank you. Yes, same thing. So pretty much you can, the same, basically the computation API is the same. The way you access data, the way you do analysis, you're using the same API. The only difference is the visualization, because the Python API doesn't have the visualization functionality. And this is where Geemap actually is good for. It's help you visualize, analyze, and also can export the data. So certainly, yeah, everything will stay the same, except that if you're in JavaScript, you create a lot of plots using the anything related to UI doc something that's not available through Python, but they're also trying to improve. And so actually, I'm working with the Google Sensing team to reorganize the code, and they are going to adopt Gmail as the official documentation web package on the documentation in the next probably 2 to 3 months. Once we finish that, we'll release. And so in the future on the documentation, you're going to see the JavaScript, you're going to see the Gmap code examples on the documentation. Thank you. So much presentation. Thank you. You mentioned so there could be a you are hosting paper backend every user there would be and then each one of them gigabytes of data. Actually, the compute is pretty expensive. So I'm wondering, like, if is it like is this like an efficient? Because like we have a lot of the compute and very powerful, but with Python backend, every user new instance data. A good question. The answer is no. It's everything's in the Google Cloud. So you can either have data access data from the Google Cloud data catalog, or you can have download data to your account. You actually access data directly from the cloud. It doesn't need any. So I would similar to like your Google Drive, right? Somebody can share a Google Drive and you can access the data directly download if you want to. But in all the scripts, all you need is just basically pointing to the data, and you can run all the analysis using a Google Cloud Compute. So there's nothing happening locally. Everything's on the server. So basically, you can think about you have the website here, the web app, and the users here, the Google server is here. So when you're actually accessing the web app, you actually go to the server, do the compute, and then return the result, visualize that. So there's basically no limitation. The limitation is what Google allows you to do that. So you can upload data. In terms of the Python, like the instance and stuff, so the web app that I show you, like at the end, that one actually it's hosting, for example, Hugging Face is all free, and I'm using the framework called Solara. So it actually allows you to turn Jupyter Notebook or Python script directly into a web app, just one line of code, and then the web app will up and running here. So far, there's not really, I mean, in terms of the instance, it's scalable because you can have 10,000 people accessing the same one. And of course, you need to have the front end server. So that one, it can be on any cloud front end, for example, Hugging Face or any Google Cloud or Amazon AWS. It's not. So essentially, you just need a server to run the package, to run the Solana package. And I think I'm not sure if I showed it. Yeah, so like in here, you can check out the repo and the web app. So you clone and deploy. Within a minute, you have the web app up and running, and anyone can access that. No, so that's Google. So what is Google essentially is free for research computation. So all the computation is happening in the Google Cloud, and it's free for research, education, and non-profit. There also the commercial version. So if you're using for profit, then you need to pay the license. But it has been free since 2010, so it's still there. Thank you.
Yeah, so we have a question. Is there a cost involved with creating web app from Jupyter Notebook? I would like to create one for water quality one.
No, it's free. Of course, if you want some of high computing power or good front end, then you can pay. But again, the web app there, the repo there, it's easy to produce. You can also check my YouTube channel. I have a video tutorial show you step by step how you create one and deploy all for free. So personally, I don't want to pay any licensing stuff. All my stuff is free, open source, open access, reproducible, and easy to use.
Great.
Thank you.
And then we have one more sort of question slash request. Can we see the QR code
Okay. Let me see here.
Any other questions in the room? Thank you for your talk. Really
Okay.
quick, I was wondering,
Yeah, good question. It's all possible, depends on the image you have. So in the public domain, in the US right now, the base, not satellite, the area imagery we have is the USDA net imagery. That one is 1 meter resolution, so you have national coverage every 2 to 3 years. That one certainly can detect some traffic, but it's like 2 to 3 years. It's not going to capture the full traffic. But if you have some other data or you have drone imagery, you have something that capture repeatedly, you can upload the data into the cloud, you can do processing. So it all depends on what you have, what you want to use. And if the data can capture it, then you can use the algorithm to detect and analyze and visualize that. But if you're using Landsat, that's not possible because 30 meter, less than 1 pixel. So you need to have at least maybe 5 to 7 pixels wide in order to be obfuscated. Basically, if human can identify the pattern, probably you can find an algorithm to do that. But if the imagery, if it absolutely cannot do that, then no algorithm can actually do the magic. So it all depends on the data you have. Thank you.
any other questions in the room?
Thank you. Huh? 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 Of course, yeah. So basically, yeah, everything I'm presenting here, I welcome contributors. And so previously, all those projects, I think this is was one of those. I have more than like 10, 15, I don't know how many projects. But you can check out my GitHub. You can search open geospatial solutions, or you can check out some of the and the QR code at the end that I showed you earlier. You can connect to my GitHub account, and then so previously under my personal account, and actually a lot of companies reach out to me. They want to use that for other commercial applications. They're welcome to use. It's open source. You don't need MIT license. All the projects, and but they're a little bit concerned because I'm the only one doing majority of the work. And if someday that I'm disappear, no longer exist, then it's people. It's not sustainable. So a couple months ago, I actually created a GitHub organization called Open Geospatial Solutions. So I moved all my majority of those popular packages into the organization, and there are a couple people in there that, in case there's a backup that I'm not there, people can take over, and then you can continue to develop and maintain. And contributions are always welcome. Tiny, small feature, even bug repo, feature requests, all welcome on GitHub. So I try my best to answer questions within 24 hours. I will implement. So I enjoy doing it. I enjoy helping people. I also enjoy creating tools that help my own research, and I also enjoy teach people how to create it. Not just that I create and use, but I teach people how to reproduce, how to start from beginning. Also in my GitHub, I have courses that teach from very beginning how to create a Python package, how to maintain, how to deploy on PyPI and Conda or something like that. Yeah. So again, welcome your contribution. If you have more specific question, talk to me. I will be happy to check. Yeah. Thank you. Okay.
All right, we do have one more question.
Okay.
So what kind of data can that ingest? That CDF or?
GeoTIFF. So for master is GeoTIFF. For vector data is SciPy, but they are expanding the data format. So hopefully in the future, maybe some support for NextDiff or pretty maybe any GDAO supported data format. That one I have no control. It's on the Earth Engine engineering team, but they are welcome to feedback. So if there's a high volume request or people ask all the time, they will ingest and improve. And they're also building the stack catalog. So in the future, you'll be able to access the data outside the Google Engine Cloud. It's coming in the next couple months. Thank you very much.
Great, thank you so much.
Sure.